Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 development stream where today we're going to sit down, we're going to use some of the fantastic libraries we've been working on, some of the fantastic APIs for 2D rendering and math, and we are going to actually build something resembling a game. You know, I was tempted to come back and do another stream of math bindings and talk about all the work I've done with that. It's kind of boring, and so I figured let's just build something, people can get it, people can play it, people can use it as an example for how to use my code. My goal is to build a collection of minigames, basically, that show off how to use these APIs and how you can rig up a full game. So kind of dog food my own library, learn some things about it, maybe get some better boilerplate, some abstractions that can go into the main scripts, like for the actual engine. I don't know. We'll see where we go with this. I don't have much of a plan, so let's jump over and let's make a plan. So I've been thinking about a game called Pew because one of the cool things I've added since the last stream is the ability to do arbitrary rotation. And so when I'm thinking about rotation, I'm really thinking about like twin stick shooters. So, a little triangle character, you can move in 4 directions and you can shoot depending on the way you're facing. So like left analog stick, I don't need to draw this. You get the idea. Left analog stick to move, right analog stick to turn. Okay, this is some fairly straightforward stuff. And then you shoot in the direction you're facing. And then maybe have some start with I guess asteroids. Have some boxes that move in off the side of the screen. You've got to shoot the boxes and you have some kind of score counter at the top. Okay, so it'll look like this. Right? It won't quite look like that actually. We're in 4:3. It's not quite that wide. I'm used to designing for widescreen, right? So we'll have some kind of HUD that'll have some kind of high score. We'll have our little triangle guy in the middle who flies around. We'll need to do some cool particle effect stuff as you fly around, shoot bullets, and have stuff moving in off the side of the screen. That's it. We're going to try and build that today. We're going to see how far we can get. So I've got a little bit of a template set up, mostly copied from my Lisp Game Jam entry last year. We're going to jump in. I was just showing off some work I'd done, off camera before I started this. So we're going to jump in. We're going to grab whatever our latest commit in this branch is. We're going to grab this commit. So my boilerplate's cool. I can jump into this makefile. I can give it a hash from my Git repository. And I can just grab that as the version of the engine that we're building against. And then we just write scripts that get overlaid over whatever's in the script folder here. So we've got our engine folder, we've got our engine/script folder, which has all of the things we need to actually make this work. And then we have our own script folder, and when I run this, these scripts get copied in. They potentially override things, but usually live in harmony next to the main engine scripts. So we can pull in, for example, all of my cool math scripts, but we just write our own logic. And this is basically how the engine's going to work, right? When you download this engine, you will get the ELF and you will get a script folder. You then kind of supplement that with your own scripts. Man, should I actually just start from a blank file? Would that make more sense? Screw it. I'm not vibing this. I'm going to delete it and start again. Let's go game door lure. Let me just... Sorry about this. I actually need to start from a blank file here. This is nonsense. Oh, here we go. Blank file, let's build something. So when our program starts up, we need to do some stuff like set up a frame buffer. But even then, I don't think that'll necessarily be the most important thing. Can we actually just run, and I haven't considered this before, can we just run a program, run a game that is just this? Okay, I think I have to call this. Yeah, cool. So script main We're going to call this script main. So what happens if I run this just out the bat? It starts up. This is our kind of like startup debug screen. Perfect. Perfect. So this is the barest thing you need to actually run something. And it's something that does nothing, but that's okay. That's okay. So there are a few things we need to set up off the bat. Let's set up the log level because this is pretty standard to do. We'll set it to debug, not to trace. There's a trace level that prints out like all of the GS draw command stuff. It's a bit over the top. We'll start with debug. And then we need to set up add DMA. We need to create some frame buffers. So we're double buffered. We need a frame buffer 1. And we get this by allocating VRAM memory, frame buffer. We use 32 bits per pixel in our frame buffer for some reason, and I think this should actually be 1024. This is our alignment, so we, in memory, get something aligned to this many bytes that can hold something of this size. We do the same thing for a second frame buffer, and we do basically the same thing for a Z buffer, but a little bit different. So same size, we use a different mode for this. It's PSM Z24. Awesome. So we've got 2 frame buffers and a depth buffer, and we use a cool bit of setup. We say set buffers, the frame buffer, the Z buffer. This is just a cool bit of overhead. Set up our render targets and then never think about them again. This is how we do it. Then we need to set up a bit of renderer state. So we have to set the screen dimensions. Screen dimensions. Cool. So this is enough to set up a basic renderer. We're not actually going to draw anything yet. To get something drawing, we need an actual draw buffer. So first, in our frame, we have to say start frame or frame start. I can never remember which order I put these in. I think in my C API, it's called start frame, and in my Lua API, it's called frame start. And then D2D frame end. Okay. But Draw2D is going to blow up if I do this as is. First off, I need to include Draw2D. So if I run this right now, what's going to happen? Oh, attempted to index nil value VRAM. I always forget. Some of these things like DMA and GS are globals. VRAM needs to actually be included. Our VRAM APIs are entirely done in Lua, which is very, very cool. And our TLB stuff explodes because we don't actually have a draw buffer yet. So we need to allocate one. Let's allocate a draw buffer that is, I don't know, a kilobyte? 5 kilobytes. Let's do that. And then we say D2D bind buffer draw buffer. And we can change draw buffers as we go. We can, draw into a draw buffer, submit that, swap to another draw buffer. We can do all sorts of stuff with this, but for now, let's just say a draw buffer, and we draw. We don't draw anything, but we draw. And we can see we actually, we can monitor our VRAM allocations as we go. We get some meaningful logging. So this is cool. This is cool. Okay. So we've done our setup. Let's change the screen clear color. Clear color. I've done things with Australian spellings, or UK English spellings, because that's cool. Let's clear the screen to red and just make sure we're actually drawing. That looks good. Let's pick a nice neutral color. What's a nice neutral clear screen color? I always have a soft spot for the one that was used in like XNA, like the classic Xbox homebrew games. I'm also a fan of 2B, a nice neutral gray. I think it's the background color of the Groovebox terminal scheme. Also very similar to the dark theme in PCSX2. Awesome. So we have a blank canvas. Now we need to think about how this game's going to be structured. So we're going to have a game state that's going to run in a loop, right? We're going to have a list of. It's going to be fairly simple. DS123 says poop brown as a clear color. I'm not a fan of poop brown as a clear color. Okay, I like something that's a little bit more inspiring. Okay, I want to feel uplifted when I look at my clear screen. I don't want to feel bogged down, for lack of a better word. Cool. So, we're gonna have some fairly standard game stuff, right? Our actual like logic loop. We're gonna have a list of entities that we need to work over. One interesting thing from the Lua front is how we actually deal with entities being removed from this list, because table remove is very, very slow. So I think for now, let's make a list of entities, and entities are never gonna go anywhere. They're never gonna die. We're only gonna grow this list. It's never gonna shrink. So we're gonna have entities. They're gonna update, and they're gonna draw. We'll have a list of them. That'll be beautiful. We need to start with a player entity, and that feels like a decent place to start. So we need some kind of game state, right? So let's say, and let's make a new file called state.lua. Okay, so what does a game state need? Function state. Does state draw? Yeah, states get drawn. State update dt. Update takes a delta time, even though that delta time is pretty much always going to be fixed in our PlayStation 2 code to the frame rate of the game. Update draw. And then we also need a function state on, I guess, pad. We need a gamepad event, right, for when you press a button. Pad, press, and then we'll also have a function state pad release. And this won't do anything, right? This is going to be a complete placeholder because we're going to return a function which takes an object. See, what I really want here is just something that won't explode. Like, I can create a state that can selectively override these things. So we're kind of going to start to get into a class hierarchy, right? Index equals state. This is gonna make sense as we go. Okay, this is gonna make sense as we go. So yeah, let's go for this. Actually, no. No. We're probably never going to include this. So we'll make a new file, script. We'll call it game.lua, sure. Local game equals something equals state. So, you know, we're kind of making a new game state that's guaranteed to, like, actually do stuff. If that makes any sense at all. Also, I need to... These are methods. So game, draw. We'll start with a draw and just see how this goes. Let's say draw 2D. We'll just draw a triangle. We'll draw it at 20, 30. Dinkelman, top of the evening. Welcome. Thank you for stopping by. Hope you're doing well. It is a very sunny morning here in Australia. I'm sure you can probably see I'm kind of like blooming on the camera because there is light streaming through my blinds into my face. It's fantastic. I need a triangle that's not going to be degenerate. So let's try and do this. I think that's okay. We have 2 points that are in the same X. I think this is a triangle. We also need to set the color. Let's draw a red triangle. So we need to. So quick note on color, okay? Because there are people who probably haven't been around since the start here. Draw 2D set color. It takes a red, a green, a blue, and an alpha. PlayStation 2 alpha is weird. It operates on a range from 0 to 2. This is fully opaque. If you go higher than this, it's like super opaque, and if you go lower than this, it's transparent. I don't know why. It's weird. Just use this value. If this is kind of like an alpha of 255 in basically every other, every other bit of code you will ever write in your entire life. PlayStation 2 is just wild. Awesome. So maybe that's a little bit of over-engineering right now, but I think it'll pay off later. Game equals require game. Let's go state, draw, and we'll see what happens when we run this. It might explode. it does, because we're indexing a nil value global draw 2D, okay? So if we come over into our game, we're using draw 2D, we haven't included draw 2D. So now if I run this, it should be fine. And there we go, we get a triangle. We get a weirdly shaped triangle, but we get a triangle. Love it. Let's add some stuff to our game, okay? So we want some entities. Hold on, I've got to bring this comment up. I've got to bring this up on stream, okay? I love this. When people said PS2 was annoying to develop for, they didn't lie. It didn't have some bizarre implementation of floating point numbers. Kind of. It actually uses fixed point numbers on the GPU. So when... so, you know, we're going to see it, right? I'm building a triangle. These are floating point numbers. But before I can submit this to be drawn, let's look at it. Let's look at the C implementation, I guess. That's a little bit simpler. Before, you know, when I build these draw buffers, I have to use this special function, this function. Oh no, 2-chord. Here we go. I've got a macro for it. Yeah, I lost it. There it is. So this converts a floating point to a PlayStation 2 fixed point number at an offset that I've kind of predefined, right? So, you know, you get the floating point part, and then you get a 4-point, or you get the integer part as like the top 4 nibbles, and then the bottom nibble is the like fractional part. It's really cool. This is a cool macro. I honestly wrote this so long ago now that my brain's kind of melting looking at it again. It makes sense, but it's weird. It's weird. Yeah, definitely like an extra thing to consider. But there are lots of good instructions that actually do that conversion, especially on the vector units. So when we do vector unit transformations for 3D later, we'll just call an instruction that'll do that for us. So our game state, it's going to have a list of entities, and that's going to be the real, like the only thing that we really do for now. So we're going to need a player. Player will live in his own little file. The first thing we do, you know, another thing we need in our state, state, we need a function when we enter our state. So function, state, enter, let's go, even game, enter, game dot entities, let's go local, we'll make a new player, we'll put him at like some arbitrary position on the screen, and then we're gonna table insert game.entities p. So make a new player, put him in our list of entities. Now when we draw the game for in ipairs game.entities do e draw end. Perfect. Return game. And we're not going to have an update quite yet. We'll get there. So let's make a new file. We'll make our player. What's our player got to have? For now, I guess he'll have an X. Oh no. No. He won't have an X and a Y. We can be very, very clever here. Let's do something that I haven't shown on the stream yet. Local m equals require math. I think I actually have to call it PS2 math because there's already a Lua namespace called math and like, oh, you know, like a global Lua table called math, and I don't want to conflict. So PS2 math is where it's going to be. Let me double check that's correct. Sure. I look like I did something off camera. I actually just stared at my second screen and didn't do anything, but sure, I'm pretty sure this is correct. So we're going to have a position, which is going to be a vector2. And we'll start it at 0, 0, I guess. We're going to have a velocity. Let's call it speed. I'm not fancy. Our speed is going to be 0. We need to remember to put commas here. What else is our player going to have? Let's give him a width. And a height. Because we're drawing him as a triangle, right? So when we draw our player triangle, he's going to have a position. And then he's going to have 3 points that kind of... I need a different color for this. Okay, so he's going to have a position and he's going to have 3 points, right? We can kind of imagine. So from here, right, this is like a height over 2. And from here to here, This is our width over 2. So we're going to define it. It's kind of like a parametric triangle, right? We give it a width and a height and a central point, and we build the actual like dimensions from there. Destro and ES, welcome. Thank you for stopping by. We're trying to build something today. It's happening. It's happening. So let's do a triangle that's twice as. Let's do this nice 3:4 ratio. So we'll start with this function player draw. So when we draw this triangle, we want to work out. Well, no, we should be fine. So we just go draw 2D triangle. The first point is going to be, so the first x coordinate, let's start in the bottom left corner. So let's do this one and work around clockwise. Sure. So bottom left corner, so that's going to be pos.x minus self.width divided by 2. And the y is going to be pos.y minus self.height over 2. The next coordinate is going to be the one at the top, so this is going to be pos.x. This is just like straight down the middle, right? And then the height is going to be pos.y plus self.height over 2. And then the last point is going to be this, but with the x coordinate, like the bigger x coordinate. Right, so where we subtracted before, now we add, and there we go, we've got our triangle. And we also need to set the color. And for now, we're just going to continue drawing a red player, but we'll make this configurable at some point. I mean, it wouldn't be hard to just add this here, but anyway. So that's everything we need. Oh, we need an initializer. So let's go function player.new. This is a function on the table, not a method on an instance. You know, Lua doesn't really give us like strong object orientation. It lets us just kind of like vibe it however we want based on meta tables, which I love. It allows us to do things in a really simple way and have a lot of flexibility about how we approach it. So player.new takes an x, takes a y. Let's go local p equals set meta table pos equals a new a new position, and then the meta table is going to be a table whose index is the player table. Easy. Isn't that just the most logical thing? Right? It isn't, but we'll be fine. Let's see what happens if I run this. It's probably an error. It is. Attempted to index a nil value. And one of the cool things about this error message is it tells us which kind of, event in our core engine it came from. So this came from our frame event. So that means that if I go into main.lua, I look in our frame event, state.draw. State.draw. So this means that our state is nil. I love this. It's perfectly logical if you know exactly what you're doing. Exactly. That development in a nutshell. Development in a nutshell. Now, I know what's happened here, okay? So we're defining our game, we're defining some stuff on our game, but we're wrapping our game in this state wrapper so that it always has the right methods. Like, it's never going to have a null thing. I don't know what's happening. My suspicion was, because it's saying that this is nil, my suspicion was that this function would be returning nil, but we do actually return something here. Interesting. State. Most of the times you don't know what you're doing. Exactly. One of the things I love most about being a developer is I get to learn new stuff just like all the time. I'd never really done Kubernetes stuff before the last 2 weeks. It had been around, it had been adjacent to my work, but in the last 2 weeks it was kind of like trial by fire. I'm doing deployments, I'm setting stuff up. It's, oh boy, I'm learning fast, learning on the job. It's great. So what's the actual error here? The actual error here is attempted to index nil value. Dinkelman, you're planning to learn Kubernetes soon and you're excited? It's exciting. It's a lot. There's a lot to learn. It can be pretty crazy, but highly recommend it. Yeah, you recently got into Docker and you're blown away with how convenient it is. It's incredible, right? Like being able to use Docker. So, I mean, I build this in Docker, right? Well, not the Lua, but the C code that the Lua then runs on top of, right? Super easy. You can just pull down the PS2 dev image, run it, it all just happens. And it means that I get the same environment here and in the cloud. And so, you know, in GitHub, I just run builds on all of my pull requests, right? Does this build? Sure. You can't download it. I think from the master branch you can actually download builds. I think I still have that on. It's just really cool, right? Like once you set it up, I think if you're signed in you might be able to see it. But yeah, like once you set it up, you can use it in a lot of places basically for free. Okay, why are you nil? Why are you nil? Let's do some debug logging. Let's go log.debug. And this should say state is nil, right? That's what we expect. State is nil. Require game. State equals... Game shouldn't be nil though. Let's see what happens. So something weird's going on here, right? State is this, game is this. So this changed when we logged more stuff out, okay? This is my favorite kind of bug. Could it be that this error is actually happening deeper inside this call? State.draw. State, sorry. Not state, game.draw. Entities, yes. It was a typo. It was a typo, there we go. That'll do it. Cool, so this isn't drawing anything. That's okay, that's okay. We've got something to work in, so let's go game.lua. We've got progress, it isn't crashing. It isn't crashing and burning. This is good, this is good. Okay, so for every game entity, draw the entity. And log that we're actually drawing something. Okay, that would explain it. That would explain it. Oh, do you know what this is? Can you see what's happened? I can see what's happened, right? We added this excellent game enter method that sets up our player, but in the actual like main, we never call enter. So let's go state. Let's do it in start, right? Let's go state enter. And now we get another error, but that's okay. That's okay. So what does that error say? Start event. This is good. We know that this is in the start event. We just added something to the start event, so this is in our on enter. Attempted to index boolean value up value player. Now here we go. This is an interesting and meaningful error, right? I don't know if I've streamed since I did this much, right? But I actually get Lua errors reported in my logs now with their line number, with their file. It's very, very important. Attempted to index a boolean value up value player, game.lua line 12. So up values are a way that Lua manages scopes. It's usually a good indication that we've either made a typo or maybe like not returned something right here. And yeah, surely enough, we build all this, but we don't actually return our table. So let's go return player. And I'm guessing it's an up value error because we're trying to reference something inside of this player, blah, blah, blah. A lot of stuff going on. We're making progress. Again, we've got this index nil value global D2D because we have not included draw 2D in our player. Yeah. And now, when we run it, we get another error. Attempt to index new value global pos. This is likely because we've just forgotten to qualify something with self. And of course it is. I actually could have really safely find and replaced there, but sure, we'll just do it this way. Self.pos and then self.pos. And now this time it's going to work. Perfect. We've got our triangle. Red triangle. Okay, so here's another thing. here's another thing we're gonna want. Okay, let's give it an angle theta. Theta is gonna be our rotation. And actually, an interesting thing when you're dealing with rotations, right? Currently, I thought we were gonna draw our triangle this way. It looks like we're drawing him this way. Do I have that right? Am I just going crazy? Yeah. Okay. He's not facing the way I thought he would. But when you're doing rotations, it's actually very natural to draw everything facing to the right by default. So facing towards positive x. Because then as you rotate, you know, you're just doing like radians around the unit circle. It's a very natural way to think about rotation. Because we're going to do rotation in radians, obviously. It's the correct way to do rotations. So we actually want this guy to face to the right. So that means that we want our points to be... We just want to swap some numbers around, right? So width is now height, and height is now width. Right? Is that right? Yeah. Everywhere we had width before is now height. Everywhere we had height before is now width. And this should face either to the right or to the left. I think to the right. Still faces down. X minus height. X plus height. Y minus... Oh, because the middle point... Hold on. I've got to do this more formally. So let's say this first point. This is... We start here. So this is minus height on 2... X minus height on 2, Y minus width on 2. That's correct. Then this next point is going to be... Well, let's do this point next, right? So this is X plus height on 2, X plus height on 2, Y minus... No, hold on. This is X minus height on 2, Y plus width on 2. And then this last point is X equals X, and then Y... no, Y equals Y, X plus height on 2. And then this is just Y. So we want to face to the right. This is going to make rotation a lot simpler. And we've got a little syntax error here, it seems. Maybe. Yeah. Yeah, that checks out. bit of bad copy and paste there. These things happen. These things happen. Awesome. We're facing to the right. And that is a wide triangle. Let's have to height on 2. Weird. We're doing something wrong here with the height calculator. Oh, no, we're not. We've just swapped what these mean. So let's go 4 and let's go 3. And this will now look a little bit better. Oh, no. Yeah, no, we are just drawing him chunky. Sure, whatever. That's okay. That'll do for now. So we don't actually want to draw this, right? We want to calculate 3 points. So we want to take... what do we want to do? We want to take our 3 points, we want to rotate them by some stuff. So we need to make 3 vectors, right? So let's do this. So let's go local p1 equals m dot vec2. So where we have this, and actually, let's just do this. Self dot local p1 equals m dot vec2. Local p2 equals m dot vec2. Also a question is, do we want to do this with vector 2s or vector 3s? I think they actually want these to be vector 3s with a 1 in the end, because we're gonna do some matrix transformation. It's gonna be very exciting. Now we have to remember what our transformation matrices look like. I mean, we actually don't. Yeah, okay, so hold on. So we're doing rotation, right? And so we're transforming this stuff. We need to rotate. So we need to assume that this is 0, 0, do our rotation, and then translate into the world, right? We have to rotate before we translate. So that means getting rid of this. So negative self-height, negative this, negative this, negative, this is just 0. Okay, there we go. Lua LSP may help, sure. Yeah, I mean, I've also just got a makefile rule, right? I've got a, weirdly enough, Lua 5.4 for some reason does not like this. I've actually got a... I've got to bump this down to Lua 5.3 for some reason, but... I've actually had no dramas just running that linter. That catches all my problems very, very easily. But yeah, I do want to experiment with setting NeoVim up as a little bit more of an IDE for sure. Okay, so there are two ways I can do this. I can either build a 3x3 transformation matrix myself. If I change these back down to vector 2s, vector 2 also has a rotate method. And I'm going to take the easy way out and just do this for now. The 3x3 matrix is cool because we could also bake the translation into it. Actually, no, you know what? Screw it. Screw the easy way out. Transform T. Do we... How do we do this transform? How do we do this? Okay, let's just build a matrix every frame. It's a little bit wasteful, but sure, whatever. Or maybe not. Maybe we build a matrix once. Transform mat3. So this builds an identity matrix by default. Then we just need to set a few things in it. So transform... okay, so what does a 2D transformation matrix look like? I always forget. I think, is it sine, cos, negative, cos, sine? I always forget. Cos, negative, sine, sine, cos. There you go. So 0 is math.cos self.theta. So 0, 1, except we're using a 3x3 matrix, so 2 is over here, and then this is 3. 0, 1, 2, 3, 4, yeah. So 0, negative, sine. And then sine, 1, 3, and positive cos. Beautiful, 4. Cool. Now we can say, well, first off, this is self.transform. Then we can say self.transform.apply. Apply. So, I've got a method in my math library to just apply a matrix to an equivalently sized vector. So like a 3x3 matrix, a vector 3, multiply it out. Because I'm already using the word multiply to mean multiply two matrices together. So if I go mat3, the problem is this... Actually, no, that's not a problem. This will update P1. This will modify, this will mutate P1. And that's okay. That's okay. So we'll do self.transform apply P2, and then P3, and then D2D triangle P1.x, P1.y. Beautiful. And this should... so apart from the fact that we've now lost our position, we're now drawing at 0, 0, this should work. And it does. We've got our little triangle up here. So now if I come down and make, for example, an update method, and I go self.theta equals self.theta plus 0 point 0.1, I guess. Actually, this has a DT, so let's update at half a rotation per second. And we'll bracket it just to be completely clear. So now we need to go into our game. For each entity, we should really change this to self. That would make me a lot less uncomfortable. Perfect. So now if I run this, nothing happens. Because if we go into our main game loop, in our main game loop, we never actually do anything. We never actually call it. So now if I call it, that may not quite be correct. That may not quite be correct. So we've got a spinny player, okay? We've got a spinny player, and that's good, but where did our position go? So in a matrix operation like this, okay? Let's add a new page. Let's add a new page. So we've got some, let's go A, B, C, D, E, F, G, H, I, and then we've got X, Y, 1, right? This is always a 1 in the last element. When we multiply this through, you know, row by a column, right? So AX plus BY plus C, right? So this C is going to be a constant. It's always going to be part of the X coordinate. So in other words, if we set C to our player position, we're just going to always translate by that much in the X coordinate, right? So like this and this always just get added on as a constant. It's simple, it's cool, it works. So self.transform2 is self.pos.x, and self.transform5 is self.pos.y. So our rotation looks a little bit funky. It looks like we've entered the third dimension a little bit. I'm not totally sure. I think I actually need to slow the rotation down a little to really see. Let's go to 0.2 per second, okay? And let's see, does this look like a stable rotation? No, we're skewing. I've done something wrong. I've done something wrong. Whatever, that's good enough for now. We'll roll with it. We'll roll with it. Actually, hold on, I can go self.pos. I can add another vector onto this. So vec2, let's add on 0. Let's go at 50 pixels per second on the X coordinate. Let's just add that onto our position. So we're going to move, we're going to spin. Nice. So now we just need to tie this into our gamepad. And there's a few ways we can do this. So first off, let's do our rotation. Now I need to remember what my APIs look like. Unfortunately, I have forgotten. I think I just say pad dot, yeah, cool. So, let's go local, let's say Rx is pad.axis right, pad.axis. So we ask the gamepad for the value of a current joystick axis. So we've got this X and this Y, okay? X, Y, we want to get the angle. And so you might think, well, this is tan, and you would be absolutely correct. And I think, arctan, sorry. So I think Lua has an ATAN method, but I think there's something about it. I think there's something about ATAN too, right? T1DX. I think this function, there's something about this function. Okay, so let's see what happens when I try and use it. let's just say self.theta equals math.atan2 ry rx. Let's see what happens when I do this. Yeah, attempted to call a nil value atan2. So this is to do with like which quadrant the x and the y are in. It's like some fancy math stuff. Like normal arctan is fine if you're in this quadrant. I don't know what's gonna happen if our points are like, you know, down here, for example. I don't know what angle it's gonna say this is. It might try and tell us it's just in the first quadrant still. So I need to plug my controller in. I keep these things very carefully catalogued, okay? This is my like PlayStation 2 controller adapter, which lives very, very carefully on the floor next to my computer most of the time. Alright, let's get a controller. I think this controller might be a little bit dodgy, so we'll have to see how it goes. This was also strangely on the floor. I've been testing out a dud PlayStation 2 I bought because I'm a tight ass, so I bought a like $20 broken PS2. And it surprisingly has been an absolute nightmare and doesn't actually work. Okay, I think I might have to... I've detected a joypad. Let me restart this and see if it actually picks up my right analog stick. Okay. Yeah. 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 It's actually very close to working. If anyone in chat knows anything about repairing broken PS2s, okay, the problem is, So I got this one. I think I've shown this on stream before, right? The disc tray is a little bit messed up. It doesn't have its cover. Maybe was used for some like swap magic stuff, whatever. It works. I've got a hard drive in it. It boots from the hard drive. The problem is there's no life in either of the controller ports or either of the memory card ports. So, bit of a dud PS2. Can't really do much without a controller. I don't know. So if anyone knows about repairing PlayStation 2 controller boards that are completely dead, like I've taken the board out, I've had a look at it, I've tried to like clean it a bit, it hasn't helped, but you can completely swap the boards. So I figure if I find a friend in Melbourne with a PlayStation 2 that they don't really care about me opening, I'll just like open their PS2, swap that board into mine, see if it works, and then at least I know that if I can find another junk PS2 with working controller ports, I can just swap that bit out of it. But then I'll have another junk PS2, and we're in a fairly small apartment, so I don't know at what point you know, I've got 2 PS2s at the moment. I might hopefully have a third soon, and then if I get another junk one, I don't know, it might start to get out of control. You know, my family are going to come in and like have an intervention because I'm collecting too many PS2s. Why doesn't this work? Why doesn't this work? Let's log debug self.theta. Let's just spew this out onto the console. If it's missing the cover, someone definitely tried to use a swap magic. Yeah, absolutely, right? So many PS2s for sale just have like dud covers like that. It's hilarious. Okay, here's a good question. Am I plugged into the right port here? Interestingly also, there's usually a light that comes in on this thing. So this adapter is like a piece of crap. It cost about $2 on eBay. Really good value, but yeah. Probably taped the lid switches. Yeah, so the lid switches have been weird, right? The PS2 had definitely been opened before. There were screws missing on the inside, which is just like super dodge. There was a really poorly installed mod chip, which I actually cut out because I was worried that was what was interfering with the controller. Turns out it wasn't, so I now just have like a ruined mod chip in there. Probably would have been cool to keep, would have been good for like PS1 backups, but anyway, I had to try it, right? I thought that was an easier thing than trying to like fix a broken controller port. Okay, so I'm not sure if this is my adapter or my code. Also, do we have... There should be some good logging here about setting controllers into analog mode, right? Found DualShock controller. So it's setting it up as a DualShock controller. Let me try my other PS2 controller. PCSX2 is closed. I'm going to replug this. Doesn't the Slim have 3 of them? 3 of what? 3 of what? Sorry, I'm not following you there. Oh, 3 internal switches. Yeah, you've got to like put the cap on that thing, and then I think it's 3. I always wanted to do it with my PS2 when I was still living at home and like a poor student. Never got around to it. I really wish I'd gotten onto Free McBoot sooner. I may have actually started doing PS2 homebrew much sooner in my life. Okay. Oh yeah, there we go. Cool. So we can spin. Our rotation is a little bit funky, but we can spin. And also, when we let go of the analog stick, we go back to 0, right? Because, and hold on, can you guys see this okay? So when I spin the analog stick, we spin to where I'm pointing the analog stick, but the minute I let go, we snap back here because we read 0, 0 from the analog stick, right? The analog stick isn't anywhere. So we need to check for that. We need to check and say, I guess we can make a vector out of these, right? So let's go RV. If RV length is greater than something, what's our threshold? Let's say 0.2, just as a completely arbitrary number. But we only update our angle if we're actually like moving the analog stick. And then we can lock into a position and keep that position. Now, of course, being a PlayStation 2 analog stick, if I like flick it around, we'll end up with a little bit of like back and forward. That's a bit gross. So at some point, I will need some kind of like buffer, right? Some kind of, make sure it isn't just a little blip in the switch to flip. But for now, this is okay. And now let's see if we can move around. Let's see if we can move around as well. It's going to be cool. It's going to be cool. Actually, let's just make a vector straight away. Vec2 pad.axis left x. What am I doing? This is all on one line now. Pad axis left y. And then we say, dear normalize. I suspect I have a normalize method, but now that I say it, I'm less confident. Vec2, I'm just going to check my math API is normalize. I do have a normalize. That's good, that's good. And then, dear scale self speed. What did I say my speed was? I didn't have a speed. How fast should we move? Maybe like 7.3 pixels per... No, hold on. I want to go much faster than that. I want to go like 85.2 pixels per second. That's actually still probably quite slow. And so then we say self pos add dear. Beautiful. And there we go. Where did we go? I don't know. That was odd. Let's go log debug moving at... Something has gone strange here. Something has gone very strange. And this is a very big number. This is a very big number. Maybe our normalize doesn't work properly. Let's just get rid of normalize for now and see where we end up. And that looks better. So okay, normalize doesn't work. We can move around, we can point. This is cool. This is the beginnings of a game, right? It's the beginnings of a little shooty movie game. Unfortunately, this has taken a little bit longer than I'd hoped, right? This stuff always does. I'm like, I'm gonna start a stream, I'm gonna build all this cool stuff, and then I get going and I'm like, man, I've gotta go do some stuff in my life. But this is cool. This feels pretty nice actually. I haven't done much I haven't done any dual analog stuff in my homebrew yet. So yeah, I can see this turning into a little game, right? Move around, shoot some stuff. Maybe wrap around the screen, or maybe have like, I don't know, move around like a dungeon. This was very smooth for some reason. I don't know. Even though normalize is broken, this was very, very smooth. So, for next time, okay? Things for me to do off camera. Okay, what do we got? What do we got? Fix vec to normalize. probably finish the math API. I'm really, really close to finishing it. I've just got a bit more to do. And then maybe some other stuff, right? This is what I'll try and get done before the next stream. We'll come back, we'll build this some more. I will get around to the Discord bot as well, but I don't know. I just felt like building something kind of more interactive today. The Discord bot, the last stream was a little bit disappointing. I don't even know if I'll put it on YouTube. I might just kind of redo the work and do it better, because it really didn't do it for me. So, this has been another fantastic stream. Thank you very much for coming and tuning in. Thank you for the wonderful people who have been chatting. I really appreciate it. Man, yeah, there's a lot to do. But there are some people getting involved. You know, the Discord has been a bit active. A couple of new faces building some stuff. So it looks like there's going to be some cool things on the horizon. I definitely want a game to be out there. And I want people to be able to see how to use my libraries. Because they're there. They work really well. So this has been a wonderful stream. Thank you very much if you're watching on YouTube. And I'll catch you next time.